Topic today is how to measure a 5G new radio service correctly, which can have a bandwidth up to 100 or even 400 MHz. 2G, 3G and 4G LTE have an occupied bandwidth which SRM 3006 is able to handle easily. The highest occupied bandwidth of LTE is 20 MHz, no problem for SRM. But with 5G a service shows up which can have bandwidth up to 400 MHz. A handheld device with such a bandwidth is not available on the market today. This video will show that such a bandwidth is not mandatory to make a proper measurement of a 5G signal. A broadband meter, as the NBM 550, has no problems to measure also broadband signals. A typical probe has a bandwidth of 6 GHz. Even 60 GHz bandwidth is available at Narda. So no real challenge for a broadband probe to measure 100 MHz signals. The broadband meter gives you the total amount of all services inside its bandwidth. In contrast, the Selective meter, SRM 3006, makes a scan of the entire spectrum by a small variable narrowband filter. In reality, not the filter is moving but the signal. But for the sake of simplicity, we will not look at that today. The additional information we will win is which frequency or service is contributing how much to the total result. So if it is necessary to find out which service is responsible for the overexposure, SRM is the choice. It is also possible to stop the scanning and to monitor a service over time. Perfect solution for finding a hotspot or monitor the radiation over long term. But what is the influence of the analyzer bandwidth, resolution bandwidth, or RBW? It can change the sensitivity of the analyzer, it can separate different carriers, but it also has an impact to the measured amplitude. And this is the point on which we have to be very carefully. If the resolution bandwidth is higher than occupied bandwidth of a service, we will not see any details of the service, but the level of the total amount of this service is measured perfectly. But we have to take care that we do not catch services that are close by. If we reduce the bandwidth to the exact bandwidth of the carrier, this will be the best solution. No interference by neighbor signals and perfect measurements of each carrier. If the RBW becomes smaller than the bandwidth of the service, we can see much more details of the signal. But at the same time the level of the service will be displayed lower than the real amount of this carrier. Clear, because every part of the spectrum represents only a part of the channel power of the service. So if we put a marker onto this result, the displayed level will not represent the full level of the service. An underestimation. In terms of health and safety, an absolute no-go. For traditional services like Tetra, FM, TV, GSM and so on, no discussion came up because SRM had always enough resolution bandwidth to measure the signals perfectly. Even 4G LTE with a maximum bandwidth of 20 MHz was no challenge for SRM. But with the hunger of more bandwidth for new services like 5G, the occupied bandwidth now became bigger than the biggest, highest possible bandwidth of SRM. Luckily, SRM can master also this challenge. Since the beginning of SRM, it has two measuring evaluation possibilities on board to handle nearly any bandwidth of service. The way out is to measure quickly with a narrowband filter inside the broad bandwidth of the service. All results obtained inside the interval are summed up, taking into account the step size and the overlapping of results. By this, it is now possible to measure a service perfectly without having a matching RBW. Even better, the result becomes independent from the chosen RBW. If the resolution bandwidth is reduced more, each individual measurement result becomes smaller, but then the process produces more results to be added up and the final result is equivalent again. Ingeniously simple and very efficient. This method is applied in two evaluation modes. First one is the evaluation mode for the marker called integration over a frequency range. The lower and the upper marker are set to the borders of the signal. The marker indicates the total power inside the selected band. This function is also known as channel power measurement. In this example, the resolution bandwidth is changed by the factor 100, but no change of measurement result. Second possibility is the creation of a service table according to the border frequency of a channel. Service tables can be created by a PC tool which comes free of charge with the instrument. After creation, a service table can be transferred to the SRM so that there is no need to carry the PC on site. With such a service table, it's now possible to make a fully automatic measurement of a 5G service. Service tables can be used not only for 5G, but they can measure any kind of service independent from its bandwidth. By this, SRM is a perfect tool to provide a measurement report at a glance. In our case, measurement results are represented in % of standard, much easier to understand for public. Finally, a code-selective measurement for 5G signals in frequency range 1 is in development at Narda and will offer the possibility to distinguish between different base stations in a single frequency environment. It also forms the base to calculate the maximum possible traffic, which makes the measurement independent from day, time, and traffic load of the system. Last but not least, an antenna for existing SRM 3006 is in preparation to extend the frequency range of SRM to 5G frequency range 2, which starts at 23 GHz. So with Narda SRM, you will be always on the safe side, or side.